I've drawn some sugar molecules here, and we're going to be identifying acetal and hemiacetal functional groups in them. So the thing to look for, since those form from aldehydes and ketones, is carbons with 2 oxygen attached. Got 2 oxygen attached to this carbon, 2 to this carbon, and the group really continues on to the next bond. So you can see that in this sugar monomer to the left, that it goes carbon, oxygen, carbon, oxygen, carbon. It looks like 2 ethers. There's the central atom, and that is an acetal, whereas this here looks like an ether and an alcohol. There's its central atom of a hemiacetal. Now, sugars are not always drawn in the same orientations. So let's look at this molecule. We're looking for those same oxygen, carbon, oxygen groups. And we can find one on each of these 3 sugar monomers. What do they continue on to? That goes to a carbon and a carbon. To a carbon, this one here continues to a hydrogen. Carbon, carbon. So these 2 are acetal groups. This one is a hemiacetal group. That should be enough to answer many questions in recognizing acetals and hemiacetals. I'm going to pull out some naturally occurring molecules. These anthocyanins in cherries. Again, this infographic is available on compoundchem.com and on my learning management system. Uploaded it for my students. Let's look at these. There are a lot of 6-membered rings. Not all of them are sugar rings. You'll notice double bonds. In a number of places. These are aromatic groups. So those are not sugars, but when you look here, there's a 6-membered ring with an oxygen in it, 6-membered with an oxygen, heterocyclic, because it's not just carbon in the ring, it's also got oxygen, and there are no double bonds. So we've got 5 sugars that we're looking at here. So we're looking for the places where 1 carbon is attached to 2 oxygen atoms. And we've identified those in each of the monomers. Now let's identify the ones that continue on to carbon. Carbon, carbon. Turns out that every one of these is an acetal. There are no hemiacetals left. Now that's something you can expect in stable natural compounds because hemiacetals are much more reactive than acetals. So these molecules are stable molecules that contribute to the color primarily of cherries. and they all have acetal groups, and none of them have the more reactive hemiacetals left exposed anywhere.